We will start the meeting 1 to 2 minutes. Let's start. We will discuss the sixth assignment. There are 32 questions. Okay, so let's start that. Will join. So today we will discuss question on the natural properties, which is sixth assignment. So first question is whose side structure is based on which type of lattice? FCC presented cubic, simple cubic, hexagonal closed plate, or decentered. So what will be the answer? Wood side structure like ZNS or ZNO as the example. So let's see the answer. Then we will discuss. Answer will be C. Hexagonal closed plate structure. HCP. How? Let's see structure formation. Example of study structure. Where we are taking the example of ZNO, zinc oxide. Let's see first layer, which is A type, O2 negative at Z equal to 0 position. This is Z equal to 0 position. Now let this is anion layer. Now Zn2 plus cation layer sit at the center like that. You can see. Let me get the rest to be correct. 1 minute. Yes. Something like that. Okay. Only people are there. Okay, so you can see atomicity here, which is Zn. This is here are the positions of the Zn2 plus, which is Z equal to, this is height, Z equal to 1 half, 1/8, sorry. Now, next layer, next layer is again 42 negative, which is Z equal to 4. First layer is this, now this is regular. Let me take this one, this layer, this Z equal to half. This is B. Okay. Now again Z Zn plus 2 at Z equal to 5/8, which is again settle down the. Okay. Now let's see the clear image output. Again O2 negative, Z equal to 1. So you can see that this is type of structure is FCP, hexagonal closed pack. Okay, so the first question, FCP. Clear? So next question, let's come on this structure. Both sides is structure. The coordination number of each atom is 4, 6, 8, 12. Yes, please. We have seen each atom. You can see from here what will be the coordination number of each atom. Let's say this atom. 3 is below, then top of 1. So answer will be 4. Clear? So let me draw again. Okay, and atom can sit like that. Also, and one more layer is top on, like that on that. So for that atom, 3 is below 1, 2, 3, and one more is top on 4. Clear? So tetrahedral coordination each atom is surrounded by 4 s, or we can say and vice versa. Next question. Which of the following compound commonly utilizing the outside structure? NaCl, ZnS, CaCl, MgO. Commonly. So answer will be ZnS, zinc sulfide. So let's discuss. We have already seen the stacking sequence of the closed ends in the outside structure is ABC, ABC, AB, AB, AABB, AAA. Which type of A, B, C, D? Which option is correct? This is the option and question. Please choose the right option. We have already discussed. Let me show you again. Let's see. This is a layer at the z equal to 0. Now B layer z equal to half, which is like that. Okay. This is B layer. this is z equal to again if we z equal to 1, which is like that, again z equal to 0, same to same, all that on the z equal to 0. So this is AB, AB again, HCP. AB, okay. Clear? Next question, the difference between the gene blend and the Bursat structure of ZNS is coordination number of the atom, bond type, stacking of the layer, presence of the interstitial sites. Yes, please. Gene blend and Bursat structure of ZNS. What is the difference? One is these are two types of structure. So this is we have already seen. This is AB, and gene blend has other type of, we have see discussed in the last class. So stacking layer. This is ABC, ABC. Clear? Let go to next question. Yes. Creating result is the ideal recipe. Packing of equal square. The atomic packing factor is A is 0.52, or in term of percentage, 50%, 60%, 74%, 78%. Yes, please calculate. You can take 5 minutes for this question and tell me the answer. We have already discussed in first class like that atomic packing factor. please answer. So as we discussed, let me show you answer will be 74% atomic packing factor. We have already discussed this type question, how we calculate. So let's move for next question. Which of the following is our true for ZMO zinc oxide structure compounds? These are the options. Please try to choose the right options. You can take 2 minutes for this question. Yes, please answer. Cation occupy half of the tetrahedraloids. The coordination number of the both cation and anion is 4. And catachron HCP hexagonal close pack lattice with the atomic position 1 third, 1 third, 1 8 and 0.005 by 8. Or anion from HCP lattice with the atomic position 0.000 and 2 by 3, 1 by 3 and 1 half. So let's see the answer and discuss. Answer will be A. First is cation occupied half of the tetrahedraloids. And the coordination number of we have already discussed this 4 and anion from the HCP atomic position. Please see outside structure and motif. You can see epoxy O2 negative with position will be 0 0 and 2 by 3, 1 by 3 and a half. So this is anion. Cation will be 1 3 2 3 1 by 8 and 0 not 0.005 by 8 will be 1 3 3 and 5 by 8. If we will change, then this will be correct answer. Okay, this will be the correct option if we do like that. Okay, and outside compound of MX stoichiometry, radius ratio should be 0.2252 0.414. An example ZNS ZNO SIC. Anion from HCP lattice with half of the tetrahedral sites with bication. Okay, an anion peak in the form of the LAB. The coordination of the fourth anion cation will be 4, same as so let's move for next question. Next, we will discuss corundum like structure M2O3. Parent compound is alumina L2O3 and other Fe2O3, Cr2O3, etc. Coordination number cation will be 6 and anion will be 4 and 2 3 filling on the octahedral bonds. Okay, let's see the structure. First plate O2, 2 negative, then second Al2O3, third O2 2 negative, second layer, then L3 and third layer and back end octahedral sides are represented by cross. All the structure consists of 6 layers of oxygen. Okay, Same limonite structure, oxygen, particular Fe2, B is oxygen again, Gi, O2, Fe, and this is the vacant apparatus section. So let's discuss question on that. Which of the following is correct for an limonite structure with the chemical formula AbO3? These are the options. Please choose the right option. So option will be A and C is the correct options. Each and B cation of one third of the alkaloids. Position number in the 9 is 4, as we discussed. Example C, cadmium, TiO3, cobalt TiO3, chromium RHO3, FeRHO3, FeO, VO3, LiNPO3, like that. Okay, and parent compound is FeTiO3. Now the Fe and Ti remain in the octahedral loads. O coordinated by 4 again. 1 minute. So these are the options correct. Let's discuss the next question. Based on the sharing of the SiO4 for negative polyhedra, which type of sharing is most preferred? Corner sharing, edge sharing, fat sharing, sharing of the hexagonal network of the SiO4 tetrahedra. Yes, please give me the right option. You can take 1 to 2 minutes for this. So you can see answer is there in the picture. You can see the corner sharing is the highest preferred, while edge sharing and face sharing the order. To minimize the cation repulsion, separation needs to last, and that's why corner wall sharing is the preferred over the sharing of the polyhedra. Next question. Which category of the silicate does muscovite belong to? Seed silicate, ring silicate, orthosilicate, pyrosilicate. Please give me the right option. Choose your answer. Yes, please answer. Answer will be answer will be A. Seed silicate. You can see in the picture double structure Si4O11 and white seed like Si2O5. So this is free mobility absence, while mica like the MSCoV belonging to this seed like structure. Okay, so we will discuss next lithium niobate, which is a structure similar to air voltage except that aluminum sublattice is substituted in the ordered manner by the lithium and niobium in the same layer, unlike the alternating layer in the FTT IoT. The material is open ferroelectric nature, sorry, is a technologically potent material that has a high anisotropic refractive index. It's so by fringes, which is changeable by the electric field using electro-optic devices. So out of the following, which material could be used electro-optic device? We have already shown you. Please choose now the correct options. Yes, please give me an answer. So we have already discussed. This is B option is correct. Lithium niobate oxide. So this is lithium niobate issues potentially in a telecommunication market. Other example also in mobile telephone and optical modulator due to its large electromechanical coupling. It is material to choices space acoustic wave devices. For some use, it can be replaced by lithium titanium tantalate. Okay, like that. So other uses are the laser frequency doubling, linear optics, focal cells, optical parameter oscillator, Q switching device for lasers, other acoustic optics devices, optical switching for gigahertz frequency, etc. It is an excellent material for manufacturing of optical waveguides. So it's also used in making of the optical special low phase anti aliasing image filters. In first few years, lithium niobate is finding application as a kind of electrostatics tweezers, an approach known as electronics tweezers as a effective requires light excitance to take place. These effects allow for the fine manipulation of micrometers scale, particularly with high flexible since the Tunisian action is constant to eliminate that area. The effect is based on the very high electric fields generated during the light exposure, 1 to 100 kV per centimeter within the illuminated spot. These intense fields are also finding application in the biophysics and biotechnology as they can influence living organisms in a variety of ways. For example, iron dog lithium niobate excited with visible light has been shown for perceived cell that in the tumor cells culture. So this is so many application of internet opto devices. So go next question. The type of the glass used in the refractory application is which type of glass? These are the four options. Please tell me the right option. Then I will discuss. So let me show you the answer. Answer will be fused silica. From the lecture, we can see as discussed what is discussed. Fused silica as a structural tetrahedral network is an this shows the high temperature. Why is used because of the high temperature window filter and application. Okay, so please remember fused silica refractory applications. Okay. Next question, let's see the number of the oxygen inside between the SiO44 tetrahedra in the case of quartz are 2, 4, 3 or 2.5. Which one? Which option will be the right? Please choose your answer. You can text in the chat box. So let me show you the right option. Option is 4. You can see SiO4. So this is SiO4 and oxygen. These are O2. So how many oxygen is bounded by silicon is 4. So that's why number of the oxygen atoms shared between, you can see here also 4. It's a simple question. Let's see the next one. Which of the following type of polymers show the translation mobility of the polymeric chains at room temperature? Fiber, elastomer, plastic, or thermostats? So answer will be elastomers. So we can see as a elastomer, the long molecular chain exists in the form of the amorphous linear bonding with the occasional cross-linking. At room temperature, the level of excitation of the chain has already overcome the secondary van der Waals bonds. However, the cross-link date exiting the structure act to revert the elastomer back to its original from the following deformation. So from the lecture, we can see also long chains with the cross-link, primary bond, and translation mobility of the chain at the room temperature double line behavior. So question is translation mobility of the polymer chain at room temperature, which is elastomer. Let's see the next question. Which of the following is are true for the thermoset polymer? They are ductile in nature. They decompose at higher temperature. They have large degree of cross-linking between the chains. Their codes soften with the increase in temperature. So let's see the option. They decompose at higher temperature and they have large degree of cross-linking. Structure like that you can see. And from the lecture, thermoplastic and thermostats, you can compare and so soften with the temperature, increasing temperature, and followed by melting, while large degree of the cross-linking between the chain 10 to 50%, very high rigidity and hard and brittle, and don't soften with the heating, decompose at high temperature. Okay, so they have large degree of cross-linking and very large or very high temperature. You can see also the explanation. Thermosetting plastic are generally stronger than the thermoplastic material due to the three-dimensional networking of bond cross-linking, as you can see in the picture, and are also better situated to high temperature application up to the decomposition temperature, since they keep their shape as a strong covalent bond between polymer chain cannot be broken easily. The higher the cross-linking density, aromatic content of the thermoset's polymer, the higher the resistance, the heat degradation and chemical death. So see the next question. If the degree of the polymerization is 40,000, then the average molecular weight in mMe of the polyethylene, C2H4, and to the power n, and dimer is. Please calculate the molecular weight. You can take 2 to 5 minutes for this question, but please solve. Let me give to you hint. N equal to, okay, and C2H4. Please calculate the molecular weight of this and multiply by n time. N will be the 40,000. H you can take 1, N 12 we can take. So total will be C2H4. What is C2H4? C2H4. So this is 28 and multiply by 28 multiply by. Now please tell me the answer. It will be that much. So which one is answer B? Okay, so B is correct answer. Did you get this explanation? Okay. Or have any doubt you can ask. Please see the explanation. For n equal to 1 equal is 28. For n equal to 1. Now we have 2n equal to 40,000. So multiply by 50,000. We'll get you your answer. Correct answer. So let's move for next question. The molecular weight in aminopolymer is chain polystyrene chain C8HF to the power n with 1000 mass is. Now please calculate the weight in amino. You can take 5 minutes for this question. We have discussed already such type of question previously. So please take and calculate. So answer will be A. Did you get the first option? Let me show you the answer. Carbon is 12 and we have 8 carbons, so 12 into 8 and 6 and H and hydrogen. One is the molecular weight for hydrogen is 8 multiplied by 8 and total will be 1044 1 n equal to 1. So we have n equal to 1000. So multiply by 1000 we will get the 1 lakh 4000. Okay, let, let's move for the next question. The example of the thermoplastic polymer is polypropylene bachelite, which is the correct option. You can choose A, B, C, and D. Or polycarbonate or vulcanized fiber. So answer is polypropylene and polycarbonate thermoplastics thermosets or polymer. So example is polyethylene, polypropylene, polyvinyl chloride, PVC, polystyrene, polycarbonate, polybenzyl, or acrylic, nylon, and Teflon thermoplastics. Next question, let's see. The side group in a polypropylene are COHH, CN, or HHH, C6H5, CH, HH, CH3, CH3, COO, and HHH, CH3. A, B, C, and D. These are the options. Please text me the right option. So let's see, the answer is D. You can see in the picture from the picture. So polypropylene, polypropylene, the side group will be H, 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 and CH3. Okay, as we can see in the picture. Next question, which of the following result in the increase in the melting temperature of polymers? What could be the reason? Presence of the double and triple bonds, presence of the bulky or large side groups, branching of the polymer chains, or absence of any side groups. Yes, please. So presence of the double and triple bond and presence of the bulky or large side group due to the increase in the temperature, melting temperature, TM, the molecular weight with respect to the temperature. If the molecular weight is increasing, the melting temperature also increasing slightly, as the molecular weight is increasing. Many mass molecular weight has many mass means molecular weight is high. So which is the first reason, and also the presence of the double and triple bonds, degree of repolarization. Molecule is tightly bound or not. If the correct statement of the following. So this is the question. Each carbon atom and polyethylene is tetrahedrally bonded to form member with the bond angle 109.5 degree. Plastic has long polymeric chain aligned in a specific orientation with the covalent bonding among the chains. Only two-thirds octahedral voids are filled by the cation in the covalent structure. So this question is mixed. The addition of impurity to silica decreasing the glass transition temperature. As we have discussed, question up to 20 based on this question. So answer C, each carbon atom you can see in picture 109.5 and only two-thirds of octahedra are filled by the cation in covalent. We have already seen this question. The addition of silica decreases the glass transition temperature. You can see two-thirds. Okay, and impurity easier melting low temperature from the forming of the shapes. Okay, so silica decreases the glass transition temperature. Next question. Butyl TiO2 has a structure cubic, hexagonal, tetragonal, or rhombohedral. TiO2. Yes, please. Structure. Choose your answer. Let me show you. Answer is C, tetragonal. As you can see from the titanium dioxide as a tetragonal, you can see result is formed by the process packing of the anion, half of the octahedral side filled by the cation, and resulting structure is tetragonal due to the slightly distortion. In isotopic diffusion, properties of cation TiO2 and large and anisotropic refractive index, high fringes using the pigments, and is not toxic. These are the properties of TiO2. So rotary structures are also ZNS, SNO2, TiO2, etc., which in option are correct. Yes, that we have seen, and also can oxide similar like tin. Titanium also tin oxide, B and C. You can see the example as SiO2, SNO2, TiO2, GO2, MnO2, BO2, niobium oxide also. These are the examples. Also, we will discuss wood side structure ZNO, ZNS, and ZNSE, cadmium sulfide, cadmium telluride, AzI, Al, AI, like that. In corundum, Fe2O3, we have already discussed these structures. The alkali structure have to belong to which crystal system? Tetragonal, we will discuss this. Obviously, let's see more. Next question. The main difference between the TiO2 and enhanced TiO2 is different type of form of the TiO2. The chemical composition, coordination number of Ti, and stacking of the TiO6 octahedra or Ti oxidation step. Yes, please. Nothing is different, only sticking. Answer is sticking. A total structure is Ti4 cation is surrounded by how many O2 anion? Yes, please. 4, 6, 8, 12. Tetrahedral we can close break. So answer will be 6 octahedra. Next, each oxygen atom in the rutile is correlated to how many Ti4 cations? 2, 3, 4, 6. So let me show you answer is P 3. The rutile structure has how many formula units TiO2 per unit cell? 1, 2, 4, 6. So answer is 2 formula per unit. Specific group for the rutile TiO2 is, let me show you the answer. So the answer is B, but what is the meaning of that? Rutile has a symmetric element of tetragonal Dravis lattice. This is P, and 4 2 is 2 axis along the C axis. That is 4 2 P 4 2, and mirror image M, and an N glide plane perpendicular to the axis, and combine this, we form again mirror image. Our next question: if A equal to 4.59 angstroms, C equal to 2.96 angstrom, what is the unit sheet volume for the total TiO2? Volume. So we have A, B, C, then volume will be this, and we know A equal to B for tetrahedra TiO2. So volume will be A square C. Please calculate this. You can take 2 to 5 minutes for this question, but solve this and choose your option. Check 5 minutes. Yes, please answer. Did you get your answer A is given 4.59 and C also 2.96. So we have calculate million square into 2.96. This is cube. Next, let me check the calculator. So this is 4.59 square divided by 2.96. This is 62.5. Let's calculate. So answer will be C. Okay, this is correct option. Did you get this explanation? So let's see the next question. The interplanar discussing G110 for the tetragonal is given and CR given. So you have to find the distance of plane 110. Yes, please calculate this question. This is necessary. You have to solve. First type of question is asking so many exams like GATE, NET, or also in the exam of this course. So please solve this question. You can take 5 minutes. We have already discussed the interplanar distance, G, how related HKL and MDC. So use that formula and please calculate. Yes, please, your answer. So D, interpolated system for, let me know, sorry, simple, 1 upon D square equal to what is? This is the relation we can use HKL, H equal to 1, K equal to 1, so 1, L equal to 0, and A and P are equal, which is 4.59, and C equal to 2.96. Please use this in this equation and solve. Try to solve this. Are you getting or not? Okay. So next question of the session. For fiber, choosing the right option. Very strong aligned and secondary hydrogen bond or rules. Sorry, I tell you wrong formula. Sorry, these directly proportional should be the length which please note this. This is the correct one. HKL. This time is directly proportional to okay. Okay. Now please let's calculate this. L equal to 0 because H K L 0. So let me put this is equals to 0. Then upon d square, this is 1. B also the same. So this is also same. This is 2 by a square of d square, and d will be a square by 2 taking roots, which is d equal to a by root 2. Now calculate a, what is a 4.59, 4.59 plus divided by root 2. This will be around 3.46 Newton. Okay, so this is the correct answer. Did you get this solution? So last question. For fibers, choose the right option. Is all of these. Very strong aligned chain and secondary hydrogen bond and pools. Okay, so this is all about today's session. We have, let me show you. We have this outside the structure question on that. Bond and type of stacking and the HCP packing. We can discuss all these things about a coronary structure. We have discussed lignite structure, question on that, and silicate lithium iodide, and fused glass like that question. Then polymers, we have discussed polymers, polymerization molecular weight, and polymer, then CO2 structure, then question on that, and finally fiber. So this is all about for today's session. If you have any doubt, you can ask. If you're not, then thanks. Let's thanks to all of you. We will meet on next Monday with seventh assignment. Please come join the session. There we will discuss again the question on the seventh assignment based question. Okay, thanks. See you on next Monday.